Okay, so this video officially kicks off our new unit on conics. We're going to start by learning about circles. The video that follows this one is going to be over ellipses. And then next week we'll finish with hyperbolas and parabolas. So the standard form of an equation is given to you in the top left-hand corner of your screen. There's a couple of important pieces of information that we have to take away from here. The first is that the center of our equation is always given by the variable h and the variable k. And then the radius of our equation is always given to us by the variable r, which is typically squared. So the reality is that you only need two pieces of information to write out the standard form equation of a circle, and that's the center and the radius. So if we move our attention to the right-hand side of the screen, I have an example where you're given the center and where you're given the radius, and so we'll plug that information into the standard form equation, giving us the equation of our circle. The standard form is always x minus h squared plus y minus k squared is equal to r squared. And so using the information that we just went over, we know that h will be 3 and k will be 7. So this becomes x minus negative 3 squared plus y minus 7 squared is equal to, and we know that the radius is 4. So then 4 squared. So let's go ahead and clean this up. Since h was negative 3 and since we are subtracting, two negative signs gives us a positive. So this becomes x plus 3 squared plus, let's drop the parentheses on k, so y minus 7 squared, and then let's go ahead and square 4, giving us 16. So the standard form equation is x plus 3 squared plus y minus 7 squared is equal 16, and this is going to be for a circle with a center at negative 3 comma 7 and a radius of 4. Here we're given 2 points. Our first point is going to be the center at negative 3 comma 7, and our second point is actually a point on the circle. So in order to get our standard form equation of our circle, we not only need the center, but we also have to figure out what the radius is. And so as we recall, the radius is the distance from the center of the circle to any point on the circle. So essentially, if we can find the distance between the 2 points given, we can find the radius of our circle. So this should take you back to the unit that we just finished, which is vectors. And as you recall, when you want to find the magnitude of a vector, aka the distance between 2 points, there's a formula that we used. So here, I can make the center point number 1, or I can make the point on the circle point number 1. Quite honestly, it doesn't matter because you're squaring the differences, so they're always going to end up being positive. So I'll just label my center as my point number 1 and the point on the circle as point number 2. So this is point number 1. And now I'm just going to plug in the information into the formula. So 0.2 x value is 8 minus negative 3 squared plus negative 4 minus 7 squared. And we're going to take the square root of that. So 8 minus negative 3, that actually becomes plus, which is 11 squared, and then negative 4 minus 7, which is also going to be 11. Sorry, it's going to be negative 11 squared. So if we square those both, we get 121 plus 121, which added together is 242. So my most simplified square root would be 11 square root of 2. And this is going to be my radius. Radius equals. And so finally, I'm going to end by plugging in the coordinates for the center and the radius into the standard form equation to give us the formula for our circle. So again, it's x minus h squared plus y minus k squared is equal to r squared. I can plug in my numbers, x minus -3 squared plus y minus 7 squared is equal to 11 square root of 2 squared. So I'm going to clean this up. I'm going to zoom out a little to give me room. So I have x plus 3 squared plus y minus 7 squared is equal to, and then we know that 11 square root of 2 squared is simply just 242. So this is the standard form equation of my circle with a center at -3, 7 and a radius of 11 square root of 2. Here they gave us a variation of the last problem, except we don't have the center or the radius. Instead, they gave us 2 points that are on the circle, and the distance between those 2 points is our diameter. So we know that if we find the distance and divide it by 2, we can get our radius, and we also know if we find the midpoint between both of these points, we can find the center of our circle. So of course, answering this question graphically is really easy because we can simply just count the distance between the points. But again, we should know how to do this mathematically. So first, we'll start by finding the diameter, which is just distance between 2 points. So we'll use the same exact equation that we used in the previous problem. Again, it doesn't really matter which point you make number 1 and which point you make number 2, because you're always squaring the differences, which means they will become positive. So I'm just going to make my red point, point number 1, and I'll make my blue point, point number 2. I'll go ahead and plug those values into my equation. So we have 3 minus -3 squared plus -5 minus -5 squared. 3 minus -3 is 3 plus 3, which gives us 6 squared. And then -5 minus -5 is actually -5 plus 5, which gives us 0 squared. And so 6 squared is 36. Plus 0 squared, which is 0, which means we will need to take the square root of 36, which is equal to 6. Now, you've got to remember that 6 is actually our diameter, so if we want the radius, we would divide the diameter by 2, giving us our radius, which is 3. So this is our radius. And then mathematically, to find your midpoint, we have to use yet another formula, which is simply just half the distance between your 2 x values and half the distance between your 2 y values. So I'm going to go ahead and plug that information in. So we have 3 plus -3 divided by 2, comma, -5 plus -5 divided by 2, which gives us 0 divided by 2, which is 0, and it gives us -10 divided by 2, which is -5. So now I know I have a circle with a radius of 3 and a center at 0, -5. So I have enough information to go ahead and plug it into the standard form equation. So we know x minus h squared plus y minus k squared is equal to r squared. I can plug in the numbers. X minus 0 squared plus y minus negative 5 squared is equal to 3 squared. We're going to go ahead and clean this up. I'll drop the 0, so x squared plus y plus 5 squared is equal to 9. So this is my standard form equation for a circle which has a radius of 3 and a center at 0, negative 5. The final way to find the standard form equation of a circle is by taking a pre-existing equation and rearranging it to give you the standard form equation. So you always want to start by rearranging everything in the equation so that you're alphabetically and also so that you have the largest exponent first. So I'm going to write this as x squared because x comes before y minus 12x plus y squared plus 10y. And then I actually just want to leave any numbers without variables on the right-hand side of the equation. So the negative 12 does not move. The next thing that I want to do is I want to complete the square, which basically means I want to create a polynomial that when it's factored, it has the same two factors. And the way that you're able to make this happen is remember that the standard form of a polynomial is always ax squared plus bx plus c. And the way that you can create a square is when c is equal to whatever b is divided by 2a squared. So I know that sounds like a lot of letters and numbers, but I'm going to show you what that looks like. So here I went ahead and expanded what's written in the previous step by adding in that b divided by 2a squared term. So when looking at my first polynomial, I know a is just an imaginary 1, and I know that b is negative 12. So if I were to plug that in right here, that would give me negative 12 divided by 2, which is negative 6. And when I square that, that would give me 36. So this would effectively become x squared minus 12x plus 36. And now for my y variable, I know that, again, a is an imaginary 1 and b is the number 10. So this would effectively become 10 divided by 2, which is 5, squared, which would give me 25. So now this would become y squared plus 10y plus 25. And remember, in the math world, if we ever do something to the left-hand side of the equation, we have to do it to the right. So the right-hand side would become negative 12 plus 36 plus 25. So if I factor my x polynomial, I should get x minus 6 squared. And if I factor my y polynomial, I should get y plus 5 squared. And if I clean up the right-hand side of the equation, I get 49. So what this tells me is I have a circle with a center at 6, negative 5. So center is at 6, negative 5, and my radius is equal to 7 because that's what the square root of 49 is. So I apologize for the length of this video. I tried to make it as short as possible, but there's just so much material to cover. On IXL, there are 2 assignments over circles plus an additional assignment over completing the squares. Once you're done with all of that, make sure you also watch the video over ellipses and then complete the single assignment on IXL that's over ellipses.